Hi guys, we're back. Week 23, science. Another fun project, right? We're going to be making an egg protector this time. And again, I want you to hang on to these because next time for week 24, when we get together for presentation, I'm going to want you to bring all the things you've created from the last 5 weeks or so, and we can show them off, right? We can have fun. So, an egg protector. We're going to build an egg protector. We're going to learn a little bit about what it takes to engineer a design that will outlast an egg drop. All right, parents, again, Nicole Liam, using her sheet, gives you all the information you need, and on the back gives you some examples, some samples of egg protectors that some kids made. Obviously, they don't have to make them like that. We want them to design their own egg protector. And our master's a little bit older. They can do some research, maybe do a little bit more elaborate stuff. So, material. We have our popsicle sticks. We have rubber bands. We have a couple of eggs, should have been a couple of plastic eggs, should be in your bag, and that you could use those to kind of test out before you actually use a real egg. Some napkins you can use, and again, they can use other materials as well as they think about engineering it and figure out what the best way is to do it. So the purpose is to build something that would protect a real egg from cracking when you drop it from a particular height, right? From a certain height. And the design, of course, needs to include a way to get the egg in and out. So you can't totally enclose the egg because if you drop it and it breaks, you won't be able to put another one in there, figure out what you did wrong. So you got to be able to get it in and out. So some things we've already learned. Do heavier things fall faster than lighter things? I think not. They fall at the same rate of speed. Doesn't matter how heavy they are. So what affects how quickly or slowly they fall? What affects it? All right, think about some of the things we've done over the past few weeks, right? So air resistance, right? The air is pushing back on it, so that's going to affect how quickly it falls. And also the aerodynamics, how it's designed, what is the shape, right? When we did the airplanes, we talked a little bit about aerodynamics, and the sleek shape would make it go faster. So if it's not such a sleek shape, it's going to go slower, right? It's going to fall a little bit more slowly. What do we notice about the different egg protectors on the sheet that we have, right? There's different shapes, what kind of cushioning is being used. Again, what other materials would be good for an egg protector? So some of the things that you're going to consider while you're designing, you're engineering your egg protector. We already know about gravity, right? Gravity is going to pull down equally on the objects dropped from the same height, right? So even if they're different weights, they're going to fall at the same speed. Okay, so air resistance and aerodynamics are going to change how fast our objects are going to fall. Why would we want to slow down the fall of the egg? Why do we care how fast it falls? Well, let's talk about Newton's second law of motion, right? That's in our memory work. Force equals mass times acceleration. That shows us if we lower the acceleration, if it slows down, we're going to bring down the force, right? How hard is it going to hit? Is that going to matter how hard it hits? Oh yeah, it's an egg shot, right? Hits really hard, it's going to crack. So if we slow it down, it's going to lower the force, right? We can help our egg land with less force if we try to design the aerodynamics that increase the air resistance, right? So like I said before, we don't want it to be too sleek. We want it to be maybe a little more boxy, a little square. That's going to give a lot more air resistance, right? So another factor to consider from Newton's second law is mass. Even though a heavier object will not fall faster, it will land harder because it will exert more force, right? Mass times acceleration. So we want to kind of make it a little bit lighter. If the eggs are equal weight, which they should be at equal weight, right, then the different weights of the egg protector is going to affect how hard the egg will land. The lighter the better. We also want to think about the stored up potential energy. Remember our two types of energy, potential and kinetic, right? Want to think about your stored up potential energy that we're going to have when we hold our egg at the top of a stairwell, a ladder, whatever it is that you're using, right? Letting go is going to convert that potential energy into what? Kinetic energy, right? The energy of movement, motion. So it's going to convert it to kinetic energy, and when they land, we want our egg protectors to absorb as much of that force energy as possible, right? So if our design can absorb the energy, we can save the egg from cracking on impact. So, what else? Last thing you might want to think about is the design of the egg itself, right? How did God design that egg? What part of the egg's shell is the strongest? And if you can figure out what part of the egg shell is strongest, then which direction should that part of the egg be facing? Up, down, sideways? So you want to think about that as well. All right, so just have fun with it. Have a great time. I attempted one. I put a napkin under there. I put some rubber bands to try to make it a little bouncier. It's not very aerodynamic. When I dropped this didn't break. I don't know, I tend to think a real egg might break. But I gave it a shot. All right? You guys will do much better than I did. I'm quite sure of it. All right? So that's it for science. Have fun. I can't wait to see all your projects when we get together for week 24. All right? All right, guys. God bless. Bye.